Welcome, Saugong aboard. Your learning journey starts now. Ever heard of DIKWP? Sounds like a fancy acronym, right? But what if I told you it's more than just 5 words? It's a framework, a system for governing how intelligent systems think and act. Forget the buzzwords. We're diving into the real deal. So, what makes this framework tick? It boils down to 7 core components. Think of them as the essential ingredients for a truly closed-loop system. First, purpose compilation. You gotta know exactly what the system is supposed to do, who's in charge, and when it stops. No vague intentions allowed. Second, semantic registration. Big words like risk or compliance aren't just thrown in. They need clear definitions within the system's context. Third, knowledge traceability. Where did this info come from? Which version are we using? Can it handle conflicting sources? Fourth, action governance. If the system takes actions, there must be rules, permissions, and ways to undo things if needed. Fifth, log replayability. Logs aren't just history. They need to let you rewind time, see exactly why decisions were made, and hold people accountable. Sixth, white box evaluation. We need objective ways to check if the system is still doing what it's supposed to, not drifting off course. And finally, boundaries and kill conditions. Every system needs to know its limits and have clear conditions for stopping or retreating. Miss one of these, and you don't have a complete closed loop. Now, here's where it gets interesting. People often get confused. They see a cool interface, a shiny demo, maybe some open source code, and think, aha, that's DIKWP wrong. This is why we distinguish between the core and engineering branches. The core, those 7 components we just talked about, is the absolute non-negotiable foundation. It's the DNA. But to actually use this in the real world, you need branches, different implementations tailored for specific industries, teaching purposes, certification, etc. Think of reference implementations as blueprints, industry adaptations as custom builds, and commercial services as the support ecosystem. Why bother separating them? Because otherwise, someone could take a slick UI or an early open source project and claim it's the whole theory, burying the actual governance principles under marketing fluff. We need clarity. The core is the core, and branches are just that, branches. Let's bust some common myths. You'd be surprised how many get this wrong. Myth 1 is just a list of 5 concepts. Nope, it's about the operational chain connecting them. Myth 2, any agent that plans tasks is a closed loop. Often they lack proper purpose, semantics, or replayability. Myth 3, RAG equals knowledge governance. RAG helps access knowledge, but doesn't automatically mean you can trace, audit, or manage it properly. Myth 4, just having logs means you can replay and audit. Only if those logs are tied back to purpose, semantics, and actions. Myth 5, one successful run proves the system works. Real validation needs consistency across scenarios. Myth 6, industry use cases define the theory. They show application, not origin. Myth 7, if the model says it understands, it's auditable. Words aren't proof of state. Myth 8, open source code automatically sets the standard. Nope, standards need clear boundaries, evaluation, and documentation. These misinterpretations are dangerous because they lead to false confidence in systems that aren't truly governed. So, how do we tell the real deal from the imitations? We use a comparative evaluation form. Think of it as a checklist, focusing on those 5 critical dimensions. Is the purpose layer crystal clear? Does it have proper semantic registration? Is knowledge fully traceable? Is action properly governed? And are logs truly replayable? Each dimension gets scored from 0 to 5. There are red lines too: no purpose, no semantic rigor, no replayability, instant fail. The goal isn't just to judge others, but to help everyone, including ourselves, understand where a system stands. Is it a concept, a prototype, a methodology, or a mature ecosystem? This framework gives us a common language to bridge theory and practice, ensuring we build systems that are not just smart, but also trustworthy and governable.